Hello, pre-calc honor students. Here we're at 12.7 determinants. That's going to have many applications for what we're going to do later on with cross products. So first, a 2 by 2 determinant. It's basically the idea of subtracting the product of the diagonals. So to do this one, we just take AD minus BC. AD minus BC. Let's try this. On this determinant, there's just going to be 3 times 7 minus 2 times 4. 21 minus 8. 13. Notice, if you switch the matrix around and put the 2, 7 on top, and the 3, 4 on the bottom, you'll get 2 times 4 minus 3 times 7. 8 minus 21 is a negative 13. So, the order in which you put vectors and so forth into these determinants makes a difference. Now, on the T99, you can do a determinant with these keys, and to find them, they're right here. You have to use these square brackets. And notice the pattern is bracket, bracket, bracket. Left bracket, right bracket, left bracket, right bracket, and right bracket again. You need a set of brackets for the sort of enclose the whole matrix, and then one for each row. Now, you don't need the commas in between the rows, but you do need the commas in between the elements in any one row. If you don't want to do commas, you can put in spaces, but I think it's easier to do the commas. Now, to do bigger determinants, we need to look at the concept of a minor. You can only do determinants of square matrices. And the matrix is composed of this array of elements, as we've seen. A 2 by 2 will then have 4 elements. 3 by 3 is 3 rows, 3 columns, that's 9 elements. 4 by 4 is 16. The minor of an element is the determinant that remains when you cross out the row and column containing the element. So let's try that with this one. What's the minor of A in this matrix? Well, to do A, we have to cross out the row and the column going through A. Here's the row. Cross that out. And here's the column. Cross that out. That leaves behind the minor of A. The minor A, in this case, will be R, F, E, L, V, M, T, N, D. It's the stuff that's left over after you take out the row and column going through that one cell. So we can find the determinant of any square matrix by expanding the minors of any row or column, because the minor is smaller than the original matrix. So you're eventually going to get down to a 2 by 2. And if you think about it, 2 by 2 matrix, A, B, C, D, if we expand it by minors, it's A times the minor of A plus B times the minor of B. Well, the minor of A is D, and the minor of B is C. But notice that this negative sign sneaks in here. And that's what I want to talk next. You have to multiply the elements in the row or column you choose by these signs. So you put down all the elements in a row or column and then multiply the ones that might be in this position by a negative. Watch how this works now. So here in example 2, let's expand by minors of the first row. Okay? There's our first row. So I'm going to jot down the first row. That is 5, 2, and 8, and then we're going to multiply by the minors of each of those and add them all up. But 2 is in a negative position in our little checkerboard pattern here. So therefore, you've got to tack on a negative to 2. Okay? Now, let's expand. Let's figure out the rest of these minors. The minor of 5 is what we get when we take out the row and column through 5, so that leaves 4, 1, negative 1, 6. When you take out 2, that leaves 3, 1, 7, 6. And when we take out 8, the row and column through 8, that leaves 3, 4, 7, negative 1. Now we can go along here. So this is, I'm just going to extend the page a little bit. So this is, let's see, 5 times 24 minus a minus 1 plus negative 2 times 18 minus 7 plus 8 times negative 3 minus 28. So you get 5 times 25 plus negative 2 times 11 plus 8 times negative 31. 125 plus negative 22 plus negative 248. 125 minus 270 gives us a negative 135. I believe that checks out. Now we got negative 145. Let's find out where I dropped something here. Oh yeah, that's what it is, negative 145. One little arithmetic error. Okay, in example 2, I'm going to evaluate the same matrix again, but by a different row or column. This time, let's go by minors. This one was by minors of the top row. By minors of the top row. Now let's do this by minors of, let's do the middle column. So we want to expand by minors of this, like that. So let's see how that works out. So let's jot down our minors first. 2, 4, negative 1. And then we're going to multiply by the, that's the row I wrote down first. And then we're going to come up with the minors of each of those. So for 2, take out the row and column through 2, you're left with 3176. 4, take out the row and column through 4, you're left with 5876. Now take out the row and column through this negative 1, we get 5831. 5831. Okay, but we're forgetting something. In this setup, 2 and negative 1 are in the negative position. So we got to put a negative here and a negative here, an extra negative. That's going to cancel that out, make that a positive. So, remember what this comes from? Back here, talked about the sign array. The 2 and the negative 1 are in a negative position, so to multiply them by a negative. Cool. So I'm just going to extend this page a bit. Work through this. Negative 2 times 18 minus 7. We saw that before, didn't we? Yeah, because that was part of this expansion. Plus 4 times 30 minus 56. Plus 1 times 5 minus 24. So negative 2 times 11. Plus 4 times negative 26, plus 5 minus 24 is negative 19. So we get negative 22 and negative 104 and negative 19, adding up to a negative 145. Yep. So the answer is agreed. Now this can be quite tedious. That's why I'm going to let you use the calculator to find these. You do have to know how to expand it by hand though for what we're going to do with cross products later on. So here's the sequence again. Notice I'm using one set of brackets just to contain the whole matrix, and then a set of brackets for each row, and separating the elements in each row with commas. So try that on your calculator. Now here's an alternative way to evaluate a 3 by 3, determine that a lot of students prefer. First I'm going to do it the old way. This is the old way. And that is, okay, the minor of A would be EF, HI. The minor of B, notice I put the negative on the B there, would be DFGI. And the minor of C is DEGH. So we get A times EI minus FH plus negative B times DI minus FG plus C times DH minus EG. So that's AEI minus AFH minus BDI plus BFG, big friendly giant, plus CDH minus CEG. And then if I group the positive parts, AEI plus BFG plus CDH, and then subtract off all these negative parts, AFH plus BDI plus CEG, you can look at these as diagonals on the original matrix. One way to look at this is to rewrite this whole thing as, that's how this works now. Rewrite it as a much longer matrix. I'm going to put in original matrix A, B, C, D, E, F, G, H, I, but then I'm going to repeat this row, A, D, G, this column I mean, and B, E, H. So now we can look at this as a bunch of diagonals. So AEI is this diagonal. BFG, big friendly giant, CDH. And you take those three diagonals, the product of the elements in those, and add them up. And then you subtract off the diagonals going the other direction. AFH, BDI, and CEG. Okay. Some people prefer that way. Now, let's try number 12 from the book to finish this up. And a judicious choice of your row or column to expand by is really key here. You want to pick the one with the most zeros, and that's this first column. So let's use column 1. So now we're expanding by minors of that column. Like that. And now you can see right away why we picked that. Because you get 2 times the minor of 2, plus 0 times the minor of that 0, plus negative 2 times the minor of that, plus 0 times the minor of that. And these are 2 and negative 2 are both in positive positions, so we don't have to change that. And I can essentially eliminate now these 2 parts. And that's a lot of work because it's 0 times. So don't bother calculating this whole determinant when you multiply the whole thing by 0 anyway. So what have we got left here? We've got 2 times the minor of 2, which is going to be 5, 1, negative 2, 1, 0, negative 3, negative 6, 4, 2, plus negative 2 times the minor of that negative 2, minor of negative 2, the row and the column here. Yeah, I was shifting this over for some reason. So negative 4, 7, 3, 5, 1, negative 2, negative 6, 4, 2. Okay, now let's practice our diagonal technique. Diagonal technique for doing a 3 by 3. It only works on 3 by 3. It sort of worked on 2 by 2, you just had 2 diagonals. But in 3 by 3, you get 2 times. Okay, let's multiply these out in our head. 2, 5, 0, 2, that's 0. 1, negative 3, 6, that's 18. And one more down diagonal. Negative 2, 1 times 4 is negative 8. Thing is minus, diagonals in this direction, 0. Negative 3 times 4 times 5 is going to be negative 60. 2 times 1 times 1 is just 2. Okay, so let's just figure out this one. That's 10 plus the opposite minus negative 58. So it's 2 times 10 plus 58. 2 times 68 is 120, 6136. Not quite done yet, though, because we have the negative one here as well. So we get negative 2 times, here's our first diagonal, negative 8, plus 7 times negative 2 times negative 6. Okay, so that's 12 times 7, or 84, plus 3 times 5 times 4 is 60. Minus, now in the other direction, negative 18, negative 2, 4, and 4 is 32. And then 2, 7, and 5 is 70. Multiplying those. So you get negative 2 times 144 minus 8 is 136. Minus, and in here we get 32 instead of 102, 32 minus 18 is 14, 1470 is 84. So negative 2 times 136 minus 84 is 52, negative 104. And when we add these two up, 136 plus negative 104 is 32. Oh, huzzah. I believe that's the right answer. Yes. Check. Okay, flange out.